guys, this is Vivek and this is the 30th tutorial of this Linux tutorial series. In the last tutorial, we saw about LVMs, Logical Volume Manager. So we saw how we can create LVM and um, what are the different components involved in LVM. So proceeding with that, I would like to explain few things when it comes about LVMs. So we also saw a few commands like PV display and LV display. So I would like to explain what all different components of these tables which are shown in PV display and LV display are. So let's start with PV display. When you type PV display, okay, I have to be a root user to make these changes. We'll type PV display, and we got that we created two physical volumes, STB1 and STB2. So the PV name. So PV names is nothing, just it maps to the device name. So the device name was STB1. Next is VG name, that is which volume group it is associated with. So volume group we named was VG-alpha. Now, what is the PV size? So we created two partitions and those partitions we allocated to PVs. So one was 2 GB and another was 1 GB. So that is the PV size. All right. Now, PE size. So these are the basic component of these physical volumes. And each of these chunks are of 4 MB size each. So if you divide this 2 GB by this, you'll get 511 units almost. So total PEs are allocated in this is 511 and just around half is in 1 GB, that is 255. Now free PEs. So we already allocated entire PEs multiplied by 4 MB, that is 2 GB. Nothing is left here, so it shows 0. Now here 255 into 2, that is 510. So still 1 PE is remaining here because it can still be allocated. So that's what it shows here. Similarly, if you type the command vgdisplay, so it shows what volume group it is. Then similarly, we have what VG size it is, 2 plus 1 around 3 GB. The PE size still remains the same because of the PE component of the physical volumes, that is 4 MB. Total is 511 plus 255, that is 766. Now you can also see how many P's are allocated and how many P's are free here. So that's all from this. If you type LV display, similarly you need to know a few components. What is the LV path that we just created? This is the path. What is the LV name? What volume group it's associated with? Then what is the LV size? LV size is of 2 GB that we created, right? Current LE it says one 512, right? So what is that? It shows the number of logical extents used by this LV. So LE usually maps to a physical extent in the VG and therefore the physical volume. Hope it clears the different terminologies used in PV, VG, and uh, then LV. So LV create, LV display, PV create, PV display. Now, next topic what we are going to see here is altering these volume groups. So first we would see how we can extend it, like increasing the size, and next we will see how we can reduce the size. So increasing the LV size is not risky because there is no data loss expected to be happen, but when you reduce the size it might result in a data loss. Why? Because suppose you have some files allocated or stored in that VG volume group. Then later, if you're or a logical volume, and if you're reducing the volume associated, then it might uh, be resulting in the situation where the size which you have reduced is lesser than the total number of files are having the size on that disk. So total files are suppose 3 GB and you are reducing size to 2.5 GB. Definitely some data loss will be there. So let's see the first thing first. So we are going to create a new disk so that we can add into existing volume group and then do LV logical volume. So let's create fdisk slash device slash SDB, right? Okay, we already have created two partitions here. If you remember, if you want to see, uh, you can see the devices created here, and make sure that the device IDs or the type are 83. Then only it can be used in logical volumes or volume groups. Now we'll create a new partition here of 1 GB in size, let's say. All right, so we'll type new partition. It's a primary partition. Default we'll leave it to 3. For sector is correct. We'll add plus 1G. Done. Now we need to write these changes. Now we need to do a part probe on this. Cool. Now we'll type fdisk minus L. It will show you the existing disks that we have. We just created STB3, 1 GB in size, right? Now, uh, so one thing you need to see that the type of these disks or these partitions should be 8E. In last tutorial, I missed to mention this important fact. So we are going to change the type of these disks, or rather not change it, but going ahead make sure that it's always type 8E. So I'm just now we created one partition, right? So we will change it to 8E. So we'll type um, fdisk minus L. We already know, so we'll type devices slash STB. Okay. Now we need to change the type. We'll hit T. Okay, it's asking with partition numbers. So we'll let's change the partitions types or all the partitions. So we'll type 1. Uh, we know that we need to change it to 8E. We'll type 8E. Now it got changed from Linux type to Linux LVM. Another partition type we need to change is 2. Again 8E. It's a hex code associated with the partition type of Linux LVM. Now again we need to change the type of partition 3. Default is 3 because it's the third one. 8E, and then we can just write these changes and then we'll do part probe. Done. Now we need to create a physical volume from this pv create. We'll add two new partitions, or we can add one partition, or let's add one more partitions here. We'll create pv create slash devices slash stb3. That's the one we created right now. Right now we need to add into the volume group, so we will type vgcreate and then we'll name it maybe Anurag, and then we'll add it, or we'll say which device, which one we created, slash dev slash, then we'll type stv3. All right, volume group Anurag successfully created out of the one new partition that we created of type 8E. All right, now we can extend the logical volume. So very first thing we need to see if there is space available. So we'll type vg display. So do you see if there is any space available? Free PE, yes, 130, it's available. Now uh, we can extend the logical volume. How? It's by using vgextend command. Vgextend, then we'll add plus 300 MB from that, where devices slash vg hyphen alpha slash Vivek volume that we created. All right, logical volume, Vivek volume successfully resized. Here we go. So initially it was 2 GB of size, now it is 2.3 GB almost, right? So you can also do a minus L with 120 M, that will be resulting in megabyte. If you do a G, it will be in gigabyte. So accordingly use the alphabets. Now you need to also extend the file system. All right, so how you can do that? So since the partition that we did was xfs, so we'll use command xfs underscore growfs, that is grow file system. Then uh, we mounted it to let's see first where we actually mounted it. Df minus h will give us where exactly it was mounted. So it was mounted MNT Vivek volume, right? So we are going to use XFS, extended file system, underscore growfs, grow file system, slash MNT slash Vivek volume. Now it got successfully completed. Data blocks changed from 524288 to 601088. So this is how we extended the existing file system. If instead of the file system that we used was of type XFS, we used a command xfs underscore growfs. Suppose it would have been an ext4 file system. Then the procedure is more or less same. Only the command which changes here from xfs growfs, it should be resize to fs, resize to fs, resize to file system. So this will be done when the file system used will be ext4. Since we are using xfs, we used the command xfs growfs. So this was about increasing the or extending the existing logical volume. What if we want to delete it? So remember I told you, if you are trying to alter it, if you're trying to reduce the size, it might result in the data loss, right? So it's not advisable always to reduce the existing logical volume size until and unless you're sure that what you are doing. All right. So since we are learning here, it's pretty much safe if we are trying to reduce the existing volume size. So we'll try to reduce the existing volume size of the group that we created. All right. So the very first thing we'll do is we will remove, or rather we will delete the existing volume group. So lv remove command is used for removing the logical volume. But if you want to reduce the size of physical volume, that also we can see, we'll type pvmove command. So pvmove is used to relocate any physical extent used in the physical volume to other pvs in the volume group. Cool. So this is how you move the physical volume from one place to another. If you want to reduce the volume group, you can simply type vgreduce command. Vgreduce. Uh, let's clear the screen first. So we'll type vgreduce vg hyphen alpha and slash device and slash stb2. It says it is still in use. That means you cannot remove it until and unless it's being used, because the system knows that it's being used and it will result in data loss. So that's how that's how we saw that how we can actually extend the file system. If you want to remove it, you can remove it using the command vg remove, and if you can want to resize it, you can always do that. So make sure guys you practice this tutorial whatever we learned today, And I'm going to teach you in the next tutorial how to remove whatever things that you added in these tutorial, the previous tutorial and then this tutorial. So how to remove the volume groups. So stay tuned. Do subscribe to this channel so that you don't miss any updates from me. Thanks for watching, guys.